Hi, good morning to all. Today we are going to discuss past year question, Chemistry SK026 PSPM 2 2016-2017, question number 1. The combustion of ethanol C2H5OH occurs according to the following reaction equation. There is a mistake in typing for the molecular formula of ethanol. It should be C2H5OH instead of C5H5OH. So I hope students will correct it. Plus 3O2 produces 2CO2 plus 3H2O, and we have to determine the standard enthalpy of combustion of ethanol. So the question sounds, when 3.68 gram sample of ethanol was burned in excess oxygen in a Bohm calorimeter, the temperature rose from 25 degrees C to 65 degrees C. 66 degrees C. Define the standard enthalpy of combustion of ethanol. Okay, we have to define. So question 1, A1. Standard enthalpy of combustion of ethanol is defined as heat release when 1 mole of ethanol is burned completely in excess in excess oxygen at standard condition. At standard condition, the temperature is 298 Kelvin and the pressure is 1 atm. Okay, that is the definition for standard enthalpy of combustion of ethanol. Heat released when 1 mole of ethanol is burned completely in excess oxygen at standard condition 298 Kelvin and 1 atm. Okay, then number 2, question 2, A2. If the heat capacity of calorimeter is 1.98 kilojoule per Celsius, calculate the standard enthalpy of combustion. Okay, so we are talking about Bohm calorimeter. So for Bohm calorimeter, right? Bohm calorimeter, Q system equals to Q reaction plus Q calorimeter plus Q water, which is equals to 0 because we assume no no heat loss to surroundings. So when we assume there is no heat loss to surroundings, our Q system equals 0. Therefore, the Q reaction will become negative Q calorimeter plus Q water. So this is the formula we use for Bohm calorimeter to calculate the heat of reaction. Okay. So moving into the calculation, before that, we see what are the information available in the question in order for us to calculate the Q reaction. So based on the question here, they give the heat capacity of the calorimeter. However, there is no information about the water. Information here, I refer to the mass of water. It's not given here. So that means in this formula, our Q water will become 0. So the Q reaction depends on the Q calorimeter. Right? So we go to the Q reaction equals to negative Q calorimeter. Since the question gives us the heat capacity, that is the C capital, right? If you see here, the heat capacity refers to the capital C. So we are going to use the formula Q equals to, so I'm going to use Q equals to negative C delta T. Okay, I'll use this formula. So the C will be 1.98. Just now we see 1.98 kilojoule per Celsius, and delta T, our delta T is 66 minus 25 degrees C. So what we can do here, we can cancel the Celsius. Therefore, we can calculate the heat release. Sorry, The heat release will be negative. Let me calculate the value. Okay, I get here. I hope students also can calculate together with me. What is the value you get here? 66 minus 25 multiplied with 1.98. I get 81.18 kilojoule. Okay, this is the heat release from the reaction. And then because we want to calculate the standard enthalpy, then we have to find for 1 mole. However, in this question, the mass given is not equivalent to 1 mole. So we have to calculate. So what we do here now, in our next step, we first calculate the mole for ethanol. So mole of ethanol is equals to mass divided by molar mass. So mass here 3.68 gram. Molar mass of ethanol is 46 gram per mole. So that means we can cancel off the gram. Therefore, we will get the mole. Okay, that is 3.68 divided by 46. So I get 0.08 mole. Okay, 0.08 mole, right? Then we can make the statement 0.08 mole ethanol releases 81.18 kilojoule. Therefore, 1 mole ethanol. Why we are referring to 1 mole ethanol? Because our standard enthalpy of combustion defined as per mole, right? So minus 81.18 kilojoule divided by 0.08 mole. Then I would get 1014.8 kilojoule per mole negative. So my conclusion, standard enthalpy of combustion for ethanol is equivalent to negative 1014.8 kilojoule per mole. Okay, that is what I get for the standard enthalpy of combustion of ethanol. That is the solution for the section A. Next, we look at the 1B question regarding the galvanic cell, 1B over here. A galvanic cell is constructed by connecting a nickel plate that was immersed into 1.5 molar nickel nitrate solution and an aluminium plate that was immersed into a solution containing X molar of aluminium ions. If the cell voltage is 1.40 volt, calculate the standard cell potential, determine the value of X. So we have to determine the standard cell potential. Standard cell potential here refers to, we have to calculate the E naught cell. Okay, sorry, E naught cell. Kita kena kira E naught cell lah. Alright. So if you take note, the concentration given here for the nickel ions, 1.5 molar, is not standard. Since the concentration given in the question is not standard, that means to solve the question 1b, you need to use the Nernst equation. So using Nernst equation. Again, I repeat, why we have to use the Nernst equation? Because the concentration of electrolyte is not at standard. So we have to use the Nernst equation. Okay. So Nernst equation, E cell, you all can check in your book as well if you don't remember the formula. E cell equals to E naught cell, minus 0, minus RTNF ln Q. Okay. So in order to define the Q, we have to know what is the Q. Kita kena tahu what is Q here. We have to define the Q. So we need to write the half equation as well as the overall half equation at anode and cathode, as well as the overall equation. Okay. Before that, we want to calculate this. We have to determine the E naught reduction value. That means I have to determine the E naught reduction for aluminium. What is the value? And E naught reduction for nickel. What is the value? because sorry, nickel, because the value is not given in the question. You can see here nilainya tak diberikan. So jadi kita cari daripada jadual, jadual SRT kita. For aluminium is negative 1.66 1.66 V. For nickel is negative 0.26 V volt lah. Okay. We have two values for, one is for nickel, which is negative 0.26 volt, and another one for aluminium, negative 1.66 volt. So based on this value, we can see that our aluminium will undergoes oxidation at anode, and our nickel undergoes reduction at cathode. Therefore, we get the half equation here. So at anode, where the oxidation takes place, aluminium solid oxidized to aluminium aqueous plus 3 electron. Okay, and at cathode reduction, nickel aqueous plus 2 electron produces nickel solid. And one can take note here, the electrons are not equal. So that means I need to multiply anode with 2, cathode with 3. So I will get 2Al, 2Al3 plus and 6 electron. Here I will get 3Ni2 plus 6 electron to 3Ni. Therefore, the overall equation, I can cancel off the electron. I end up getting 2Al solid plus 3Ni2 plus equals produces 2Al3 plus equals plus 3Ni solid. Okay, we will get overall cell reaction. Okay, this is important. Overall cell reaction is important to write the Nernst equation Q, right? To define the Q, we need the overall cell reaction. Then we can define the Q. So coming back to the formula again, E cell equals to E naught cell minus RT and F ln Q. Now we can define Q. To remind you all, Q here is product over reactant, ataupun kanan bagi kiri. Okay, you tengok kanan siapa, kiri siapa lah. And bear in mind, when you look at the overall equation, that is what is in the left hand side and right hand side, solid are excluded, dikecualikan. Solid tidak dimasukkan. Kita hanya ambil aqueous sahaja. Okay, kanan bagi kiri lah. So we will have Al3 plus Al3 plus power 2. Okay, jangan lupa ada power 2. Kemudian Ni2 plus power 3 divide by Ni2 plus power 3. Okay, this is our Nernst equation, how we define Q. So going back to the question, the first part they required us to calculate the, if you look at the question, the first part they want us to calculate the E naught cell, right? So kita pergi formula E naught cell. Alright, E naught cell equals to E naught oxidation plus E naught reduction. Okay, E naught oxidation you can see here. Alright, in this reduction format, the value is negative 1.66. Once we reverse this into oxidation, maka dia akan jadi positif 1.66 sebab dia mengalami oxidation. For nickel, no problem. It is originally in the form of reduction. So we take this value lah. That is negative 0.26. So what is the value we can get here? Kita cuba kira 1.66 minus 0.26. I get 1.4 positive 1.4 or 0 volt. Okay, positive 1.40 volt. Okay, next we can solve the B, not B, number 2. We can solve the number 2. Number 1 already settled. Number 2 now is determine the value of X. What is X? X is the concentration of aluminium ion. Okay, so we go to the formula. We substitute all the required information. So E cell is given in the question. Tadi kita baca E cell, they said 1.40 E cell. Okay, tak apa saya tunjukkan. Yeah, the cell voltage 1.40 merujuk kepada E cell. Okay, E cell. Then concentration of nickel pula they give 1.5. Okay, so gantikan semua ni lah. Inert cell tadi kita dah kira 1.40. R is 8.314. T is, what is the temperature the experiment conducted? They don't mention over here, do they? No. Oh, that means I have to change the formula. I use the log formula because the temperature is not given. If I want to use this formula, I need to know the value of temperature. So I use E cell equals to E naught cell minus 0.0592 over N log Q. Al3 plus power 2 and I2 plus power 3. Okay, so I use this formula. So 1.40 minus 0.0592, this will be 6 because the mole of electron transferred is 6. Okay, 6. And here log Al3 plus, the concentration is what we are going to find, X power 2. Nickel is 1.5 power 3. Therefore, value of X berapa? Okay, kita kena kira lah. I get the value 1.84 molar. Okay, for the this 1.84 molar is the concentration of aluminium ion, right? Just one more thing before we end. Why do I switch from this formula to this formula? Just because of the temperature, because the temperature is not given in the question. So I have to use another formula of Nernst. Okay, depends on the question, right? Now we look at question 1C. Electroplating is one of the techniques used as protective coating for metals. A student is requested to electroplate the iron nail with tin. If a current is passed through the electroplating solution, write the half equations at anode and cathode. So for the first part, they want us to write the half equations at anode and cathode. And then they ask us to predict what happened at both terminals. It's like observation over there. We should state the observations, what happened at anode and cathode. Okay, so that for me, the understanding of the question begins with the diagram. I need to understand through diagram what is happening. So imagine we have a beaker, right? We have a beaker, and then we have iron nail over here. Okay, iron nail. Okay, and it is immersed in SN2 plus aqueous lah. Okay, the electrolyte should contain the ion that we want to be, the ions that we used to be electroplating, that is tin over here. And we also need what we call as a tin plate lah, tin plate or tin electrode. And they are connected to battery, of course. Obviously, we have ammeter, then we have rheostat and so on. Okay, all those things are, sorry, the other way. The rheostat and everything else. Okay. But the most important thing is our understanding who will be the anode and who will be the cathode. Okay. In this case, because kalau kita baca soalan, they want to electroplate iron with tin. So definitely our tin has to be the anode lah. Tin has to be the anode. Because then only at anode where the oxidation takes place, um, tin plate will dissolve to produce tin ions and electrons. So oxidation takes place. So at anode, oxidation produces tin 2 plus ion. And what happens when the ions are produced over here? Sorry, when the ions are produced over here, Sn2 plus. What happens next is at cathode, where reduction occurs, that tin ion, which is oxidized and released at anode, oxidized and released at anode, will travel to the iron nail. Okay, when you go to the iron nail, then the reduction takes place. So iron nail, the tin which travels to iron nail, our cathode to be reminded to you is the iron nail line. So when the tin travel to the iron nail, it will be reduced. That is reduced become tin solid. Okay. So what happened now? This tin solid will begin to deposit on the surface of iron. Okay, begin to deposit on the surface of iron, and this deposition on the surface of iron nail we call as electroplating. So now our iron nail is electroplated with tin. This is the idea, the basic concept of electroplating. One side, the metal will dissolve, oxidize to produce ion, and that ion goes to the other side, that is cathode, get reduced and deposit on the surface. In this case, it deposits on the surface of iron. So we successfully done our electroplating. To be giving you some additional information about electroplating. Electroplating, the object that need to be electroplated have to be consistently rotated. Kita kena selalu putarkan, pusingkan iron nail ni sebab baru dia punya electroplating tu nampak cantik, seragam pada seluruh permukaan paku besi itulah. Okay. One thing. The second thing is we have to use consistent current. Sebab tu kita gunakan rheostat to make sure the current that travels through this electroplating process is consistent supaya dia punya surface cantik di electroplate. Kalau tak nanti, kalau current tak cantik, dia keep on fluctuating, nanti satu belah paku tu nampak tebal dengan tin, satu belah paku tu nampak macam tak ada electroplating langsung. That is the reason lah. This is just extra information for you. Now the second part, they want us to predict what will occur at both terminals. Okay, so here my answer will be at anode lah. Kita tengok at anode dulu. Atau saya tulis kat sini. Boleh tak cukup ruang. At anode, what could I see here is we find what we call solid. Solid ataupun tin plate lah. Tin plate oxidize. Satu lah. Oxidize and becomes thinner. Okay, that is what I can see lah. It produces tin 2 plus ion. Okay, whereas at cathode, what happened is S2 plus ion reduced at reduce not add reduce to S2 ion produce, wrong sorry, just a moment, I read against it. S2 ion produced at anode is reduced is reduced to as an atom. Okay, Sn2 at cathode, Sn2 plus ion produced at anode is reduced to as an atom, which will be deposited, on iron nail. Okay, S2 plus ion produced at anode is reduced to as an atom, which will be deposited on iron nail. This is what happened. Huh? Hi, good morning. Today we will continue with question 2. D is isomer of an alkene with molecular formula C6H14, which poses a quaternary carbon. The reaction scheme that involves D is shown below. So we can see B C6H14O reacts with concentrated sulfuric acid heat, we get C6H12, and then react with hydrogen in the presence of palladium, Pd, we get C6H14, and then we do bromination, bromine in the presence of sunlight, we get E as the major product. So question number 1, dehydration of secondary alcohol B produces C. Suggest the structure of B and write its mechanism. Question 2, suggest the structural formula of C and D. E is the major product of reaction D with bromine in the presence of UV. Draw and classify structure E. Suggest a chemical test to distinguish C and D. Write the chemical equations and state your observations. Okay, so we start with the D. Kita kena mula dengan D. Excuse me. Because D is where the clue comes out, possesses quaternary carbon, right? So we go to D. D possibly CH3, C, CH2, CH3, CH3, CH3. Okay, this is the quaternary carbon. This is the possibility of the quaternary carbon, right? This carbon can become a quaternary. Let's say this is our D, for example. So we have to work backwards now. We have to work backwards to get the C. And since this is hydrogenation, so C must be an alkene. Okay, C must be an alkene. All right, so the possibility of alkene is this one. We go to C. I go to the next page. Kita punya C boleh jadi macam ni lah. C can be CH3, C, CH3, CH3. Sini CH3 sini sorry. This is CH3, this is C, CH double bond CH2. Okay, you can see here because our location of double bond, kita boleh letak double bond kita sama ada di sini sajalah. Saya nampak sini saja. Ini saja possibility-nya. This is the only possibility you can put double bond. Sini semua tak boleh. Nanti dia akan jadi 5 bonding kan. 5 bond which is incorrect lah. Even if I reduce also then tak logic. Dia memang dah penuh kan. Quaternary memang dah tak boleh letak double bond. So tinggal ni sajalah. Okay, so then the only option we have for our C is like this lah. This is our C. This is our C. Okay. Then from C we can get the B, right? Kalau kita tengok daripada C kita boleh dapat B ya. B must be an alcohol. Alcohol sebab kita guna concentrated sulfuric acid. So B alcohol dia kat sini lah. Dan same lah CH3, C, CH3, CH3. Kemudian sini CH, OH, CH3 lah. This is our B, alcohol kita kan. So we go back to the answer A. We go to answer A. Not A. We go to part 1. We go to part 1. The addition of alcohol B produces secondary alcohol. Yeah, they already mentioned a secondary alcohol. So do we get secondary alcohol here? Yes, we get a secondary alcohol. That's true. So confirm ini B kita lah. So they said suggest structure of B. We already suggest mechanism for the transformation. So we go to the mechanism. Okay. If you remember, this is mechanism dehydration of alcohol. So step 1 is protonation of alcohol. Protonation of alcohol. So I got CH3, 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 then CH3, OH, 1, 2, 3, 4, CH, CH, okay, then plus with OH, H, hydroxonium ion plus, okay, then let's say I take this proton, so I use red color, yang ini ambil proton ini, yang ini return balik ke oxygen. So we get protonated alcohol, CH3, 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 CH, CH3, H, OH, double dot, H. Okay, there's a plus over here. Ataupun plus di sebelah sini. This is our protonated alcohol. And then kita ada OH, H, double dot. Kita punya conjugate. Sorry. Sebabkan ini acid, hilang proton, we will get a conjugate base. Okay, this is step 1. Step 2 is formation of carbocation. Formation of carbocation. So we get CH3, C, CH3, CH3, C, CH3, H, O, H, double dot H plus, kan, sama macam tadi ya. Okay, and then what happens here, this bond, there's a break over here because our oxygen is more electronegative than carbon. Okay, oxygen more electronegative than carbon, then it breaks that B, then we get CH3, C, CH3, CH3, C, CH3, H plus, then we get H2O here lah, right? Ataupun kalau tak nak buat macam ini, sebanyak tunjukkan dalam bentuk Lewis structure atau kita faham lebih bagus, sorry, H2 kat sini. Kita ikut apa yang kita buat di sini lah. Satu H di sini, satu H di sini. Asalnya ada di sini, so bila bonding electron masuk ke sini, jadi water lah, dapat water lah. Okay, then we get, we can label the class of carbocation. We get a secondary carbo, ataupun saya gunakan pen warna lain. Secondary carbo, okay, ion. Then going to the step 3. Step 3 is normally we have, sometimes we don't have lah. Is there any possibility of rearrangement? I think if we rearrange, then we can't get what we look for the answer just now. Our answer we already fixed. This is our C, this is our B, and this is our D. We already fixed all these things. So if I go to the possibility of rearrangement. There is no rearrangement because kita dah fixkan ini adalah C kita. So there is no rearrangement. Maka step ketiga kita terus masuk removal of proton. Removal of proton. Right? Removal of proton. So we bring our what we call our carbocation here. Then we have proton here. This is our carbocation. We have CH3 here. This is our carbocation, secondary, right? And we have our what we call, bukan water, kita punya conjugate base balik. Okay. So what happen is the conjugate base now will remove this proton. It will remove. I think I have to expand lah, sebab kalau tak expand tak nampak kot. So this part I expand supaya anda boleh nampak. Dan saya gunakan warna yang berbeza. Kita ada 1 proton, 2 proton, 3 proton. Salah satunya conjugate base akan remove lah. Katakan dia remove yang ini. Okay, bila dia remove proton tu, what happen is, just show here, this bonding akan jatuh di sini lah, between carbon cation and carbonization. Okay, I repeat again. This bonding yang di antara carbon dan hydrogen, yang kita remove proton ni, maka bonding ini akan jatuh di antara carbocation dan juga hydrogen carbon. Carbon bersebelahan. So kita akan dapat CH3, C, CH3, CH3, kemudian C, H ini masih adalah double bond C, H, H, plus O, H, double dot, H. So kita dapat acid kita balik dan kita dapat structure C kita lah. Okay, this is the mechanism. So we just go once more check. Is our drawing and C is the same? Kita tengok. Yes. Is it correct? CH2 lah. So we get CH2. Correct. So we get the same answer lah. To how to get the mechanism of B becoming C. Alcohol tukar jadi haloalkane. Alcohol tukar jadi alkene. Okay, sorry, alkene. Alright, so we have just now we have seen we have completed the mechanism. Sudah. Structure C and D also sudah. E is the major product of D in the presence of sunlight. Bromine, draw and classify structure E. So sekarang kita lukis E from D lah. This is our D. So we go to our D was like this. Our D was CH3, C, CH3, CH3, CH2, CH3. So kalau kita buat bromination, the most stable will be replaced. So that means dia akan jadi sini Br akan masuk, sini kekal CH3 lah. And then this will become our E. Okay, that is our E structure, where you find the bromine is replaced at the secondary carbon. That is the most stable you can get for the bromination. And then they ask us to classify, then this is a secondary haloalkane ataupun alkyl halide. Okay. Alright, next question. Next question is this one. So we have completed this one, draw and classify. Draw, it can be skeletal, expanded or condensed, up to you. Suggest a chemical test to distinguish C and D. Distinguish C and D. C is an alkene. D is an alkene. Okay, so alkene and alkene. So we go to chemical test to suggest a chemical test between alkene and alkane. The easiest I would say is the bromination test lah. Bromination ataupun halogenation bromination bagus kot. Bromination test. So we have the chemical reagent or reagents used. Here we use bromine in dichloromethane, right? Dichloromethane. The condition, physical condition is dark, dark, and room temperature, dark and room temperature. Then we have that's the first one. First one is name. Second one chemical test. Sorry, apa sana? First is name. Second is chemical reagent. Third is physical condition. Uh, Fourth is observation. Observation. So um, for C, for C, um, reddish brown color will be decolorized, will disappear lah. Reddish brown color of Br2 decolorize. Okay. For D, reddish brown color, uh, reddish brown color remains unchanged. Remains unchanged. No? Okay. And we go to the fifth one, the final one. We need to give the equation. Right? Equation, sorry, not equation. Because equation only for the positive one, that is our C. So we have CH3, C, CH3, CH3, CH double bond, CH2, C, then Br2, UV, okay, and we get CH3, C, CH3, CH3, CHBr, CH3. Okay, that is the equation. So going back to the question, do we manage to answer all the things? Yes, suggest a chemical test, write equation, state the observation. Done. All right. Thank you very much.